Hello, everyone. Welcome to AWS UserGroup. My name is Timur. I'm going to host this meetup today. We have pleasure to be hosted today by Idealo and are thankful for this opportunity. Today is the session number 112. We are trying to conduct our sessions monthly when we can. And this week we had a milestone of surpassing 5,000 members in the user group on the meetup.com. A lot of applause. As I said, it is sponsored by Idealo, and I would like to also present the core organizer board, which are Aaron over here. James, unfortunately, is not with us today. My name is Timur. Kadir is here. Kadir is there, and Daniel is over there. We are doing that in our free time and our nonprofit. So we could also give a big applause to this group for working on that. Quick agenda for today. We have two topics. One presented by guys from Idealo, from Ajay and Pasi. Hope I pronounced their names correctly. They're going to speak about Karpenter and I think migration to AWS. And then we have a second talk from Maximillian from AWS, who is somewhere over there. He'll present us some insights about load balancers, different kinds of, and stuff like that. And today we will have a live Q&A session. You can give us feedback. You can ask questions. Also, don't hesitate to ask questions to the speakers via Slido. Just scan the QR code. Slido is sponsoring our license for Slido. So, yeah. Okay. All right. And there's quite a big announcement. I'm pleased to say that there's a new AWS user group dedicated to women. And today we have Sana and Galina, who will tell you a little bit about this new user group that will start functioning in about 2 months from now. So I'll welcome you on stage.
Thank you. Hi, everyone, and thank you to the AWS UserGroup Berlin for giving us that space. So the past couple of months, we've been working on an idea, and that was to actually found a user group for women dedicated to the needs of women and specializing on AWS. So I'm happy to announce that the idea has finally become reality and will be starting soon. And this is the first AWS women's user group in all of EMEA. Yes. And this AWS Women's User Group will be based in Berlin, and we are officially launching it in September. The goal is to address the gender gap that we have in cloud computing. Just to give you an idea, the World Economic Forum did a global gender gap statistics survey in 2021, and it said that there are only 14% women in cloud computing, and it's a global statistics. So the number in DACH and in other regions are also lower. So we want to address this gender gap and also focus on the needs and challenges that women have specifically in this field. So the content will be AWS knowledge sharing, best practices and trends, but we will also have always like a community forum where women can share their experiences and whatever they need in order to advance in this field. We will focus on beginner to intermediate level because there is already a user group focusing on advanced content. We are also working closely together with this user group, and we're happy for their support and already grateful for everything they have shared with us. We will start with a bi-monthly frequency, so every 2 months. The first user group will happen in September, 26th of September, and we will be announcing it very, very soon. So there will be a meetup group and everything coming soon. We're just lagging a little bit behind, but we wanted to use the opportunity already so that you can share it with anyone you know who might be interested. Currently, I am actively looking for other organizers who would like to run this user group with me. And so I can share my LinkedIn here, and yeah, you will find more information on the meetup, and we will share it with this user group, so you will have all the information. And I just wanted to give Galina also the opportunity. She's here from AWS, and AWS is also supporting this initiative.
Thank you very much, Sana, and thank you very much for running this initiative. Hi, my name is Galina Atamankina. I'm an AWS technical instructor, and I'm championing the creation of the user group for women in Berlin on the AWS side. And I'm really excited this happening, and my colleagues, community builders on AWS side, they are also happy about it. This will be the first one, not only in the DACH region, but in EMEA, as Sana mentioned, and I hope it will give the opportunity to many female colleagues to share their experiences. It will give the stage to female colleagues to present their topics, advances, and to expand their knowledge. So please share the information about this user group with your female colleagues. Female colleagues, please join our meetup, and see you soon.
And if you have any questions, we will be here later if you want to talk to us. Thank you.
All right. This is actually a moment where Enrico from Idealo would like to give you a small introduction about the company.
Okay, so now a notice for all the facts. Yeah, so my name is Enrico. I'm a system engineer at idealo. I'm member of the operations department and of the idealo meetup. Give me a sec. This is also planned, of course. Nice. It's enough, or it's enough. Okay. So yeah, and I'm part of the meetup idealo organization, and yeah, it's a pleasure for me to say hello and have a warm welcome here. And yeah, let's start by saying it's a pleasure to host a meetup for you here. It's the first time that we have a meetup here in this new building, and yeah, we hope that is a good time for you and that you enjoy the evening. And now some facts about our company. So perhaps some of you use our service or know about that. Idealo company was founded in 2000 as a price comparison company, and since 2006 we are part of the Axel Springer group. Currently we are live in 6 European countries, so Germany, Austria, France, Spain, the UK, and Italy. So that's nice. And we have more than 6. Okay. Please fix it. Weitermachen, okay. Yeah, so we have more than 76 million visits per month. We have more than 50,000 shops on our page with more than 530 million offers for what was it, 3.7 million different products. So that's nice. No, it's not Linux. Ah. No. Sure. No. Yeah, we are more than 1,000 employees. 400 of us are ITler. We have 30 engineers, and more than 370 are developers from more than 60 countries. But what's our connection to AWS? Ignore it. Nice. You fix it. Yeah, it's clear. Okay. That's, yeah, technique. Okay, what's our connection to AWS? For more than 2 years, we started our journey, a migration path to move to AWS, with the goal to have an all-in after that. That means for us, we want to have to finished and closed our data center. This created for us big challenges because, the business must go on every day, and we are a big IT department, and to coordinating this who, what, and when was a huge number of staffs and teams that we have in various systems, was a very, very problem for us and not so easy. But we hope that we can achieve this goal in the next months. And that's also part of the next presentation of us. But before I hand over to my lovely colleagues Pasi and Ajay, the most important information for you. You can find cold drinks in this freeze. And after the first presentation, you find on this table, of this round table, the food. Okay. I hope you enjoy and have a nice evening.
Okay. Usually with a mic it works, so let's try.
Yep. So, welcome. Let's wait a sec. We get connected here. Yeah, but anyway, maybe I could just say that it's really nice to be such a big crowd here. We are quite surprised, let's say so, but this is really nice. Yeah.
Try again, maybe keep talking.
Okay.
Sorry. Yay!
Ooh. Woo. That wasn't so difficult, huh?
Okay, thanks Rico for that wonderful initial presentation, I would say. Just a round of hands, how many of you all know Karpenter and use it? Okay, not much, but good. How many of you all use cluster autoscaler and use it? Okay, then Karpenter wins. Some information about us. So hi, I'm Ajay, and I'm a senior cloud engineer at idealo, and I work for Team Compute. So I originally hail from Bangalore, India. I did my master's here in distributed systems, and now working here since a year and a half right now. And Pasi?
Yes, so my name is Pasi Romo. I come from Finland originally. When I was living in Finland, I used to work for Nokia. I think half of the engineers probably did. And then me and my wife, we got this bright idea that how about there's this city called Berlin, and then we moved here, and then we fell in love with this city and basically stayed here after that, and now I found my base also here at idealo, and that's basically it.
Cool. Yeah, then Pasi
Yeah.
will start.
So I'll start with this one. So Rico was so nice to ask us to give a presentation for this meetup. It would be a really nice opportunity to tell you something. And it's quite we were with Ajay thinking about it, and it was a bit challenging because we are actually in the phase of doing the migration. So we are still like learning all these things and figuring out what would be the best way to do things. And then we were thinking that, okay, what could we then tell you about? And then we think about like what is idealo actually. So we're a price comparison site and like working in a compute platform team. So what it means for us is that I call it here like a seasonal workloads, that we get traffic, but it really depends on the time. So like it starts like already during the day. You think that, okay, maybe nighttime, there are not that many people doing purchases. But then during the day, there are more. And then if you think about the whole year, then there are also like special times, like let's say we have Christmas or we have like Easter. And nowadays, the Black Friday is the biggest stress test that happens every year, and today and tomorrow is the Prime Day. This is also really important for us. And so we thought, okay, maybe we tell something from this side, and also actually give you kind of like a story about this, that how we actually ended up here. So where we come from, what we are doing now, and where we are maybe heading to. And then we thought, okay, let's look back and what did we do and how did it work out? And because we already mentioned this Black Friday, we thought that, okay, let's tell about Black Friday, but how it was in data center. So how it felt like. Maybe I need to explain this dinosaur here. So it's just dinosaurs are really cool. That's one thing. But then another thing, it's just a personal thing, when I was looking at this picture, was that it reminded me of telling stories for my children, and they would ask this question that were there also dinosaurs at this time, and of course there were. Yeah, so it's kind of related. So this is like the kind of timeline if we think about what it looks like when we were running in data center the Black Friday. So where we start here in the beginning, we can say it's like we have just been able to go over the previous Black Friday, and then we need to start thinking about the next one. Maybe we did some learnings about this time, and then based on this, we need to think about like the capacity that, okay, maybe next year how much do we need to increase? Then we make some estimation, and then this estimation is basically for the whole year. So it's like we're running Black Friday capacity the whole year, because there's no way just to scale it. We buy it, then we have it, but that's it. Then we actually do the process. That's the fun part. So we buy, we order stuff, then at some point it arrives. We have a data center somewhere, then we start to create tickets that the people would go there and install actually the servers there. And then let's say that maybe the hardware architecture changed. We have a new version from the hardware, so then we need to start changing the automation, how we get these servers into use. And then in the end, everything is set to go. We can start sharing this new capacity with the teams and giving them where to run things. And then we are basically set for the Black Friday, but maybe, I don't know, maybe we still run out of, like, maybe we could squeeze somewhere a little bit more. And then we start to like moving stuff from staging or testing to production, maybe send like an email to teams that can you maybe somehow make it free some resources. But in the end we are really, really confident, and then we can just pray that everything works. And sometimes it works, sometimes not. Sometimes we have incidents, but that's the way what the life is of an engineer in the data center. And actually, we kind of also get good with it. So we practice, we do it every year. So we kind of have already this kind of experience about it. But then we hear that there's this thing called cloud. Maybe it would be somehow different. We look at these different providers, make a wise decision, of course. And then we end up that, okay, now we have some new challenges that we need to think about. So it's not so that the capacity is somehow fixed, but now there's like a unlimited capacity. So how do we handle this part? So as you see, there's this cow, the rancher. So already in the data center, we are using Kubernetes. We are running it on Rancher. So we have experience about running things on containers. But the thing is there that it doesn't scale anywhere. So there's a hard limit. When we run out of capacity, then that's it. But how about here? We have the unlimited capacity. And in this case, then we need to start thinking like, how do we make wise decisions when we are using it? How do we make it as easy as possible to use all this capacity? And yeah, another thing, or like a benefit that this going to the cloud brings us is, of course, that we get better cost transparency. So when so in the data center, we had all these servers bought, but we didn't really see that how much does it then cost when there's a specific team who is using this capacity. So here in this case, we can make it much more clear and see what teams are using. And yes, and because we already had experience with Kubernetes, we decided that then we go on with EKS. And in EKS specifically, then we think about that what would be then the tool that we could use for this to like managing the nodes and servers somehow intelligently. And then we looked for options, and then there are these two that Ajay will now tell about.
Thanks, Pasi. Yeah, so probably a nice story that you all heard from Pasi of the entire journey that we had there. So yeah, now we chose our cloud. Now we need to choose how do we scale our instances. Back at the data center, it's quite not so easy. There's a huge process for it, and you need a lot of people for it. But once you're in the cloud, it's really easy. Yeah, so we have two big scalers that you could use. So of course, it's a fight death match between cluster autoscaler and Karpenter there. Most of you know, or maybe some of you know, that the cluster autoscaler is quite mature. It's battle tested for a really large number of node set. And primarily, it's managing nodes via autoscaling groups. This is a bit primitive for us when we thought about it, since we want to be cool and go really into the cloud. And yeah, but also it supports several cloud providers, but we don't care because we went AWS. Yeah, so a bit about Karpenter. So it's basically looking at your workloads and not looking at node utilization like what cluster autoscaler is doing. So it's more looking into how your workloads perform and spinning up nodes for that. Also quite really nice is the concept of spot nodes that AWS or any cloud provider would bring in, and Karpenter fuels this as well. Yeah, so also, probably even something about multi-architecture images. So you could leverage that, and this is by default done by Karpenter. And also kudos for this spot termination handling, which is natively used by Karpenter now. And last but not the least, I think it's taken over by AWS now, and there's a huge community support out of it. Yeah, so now we chose Karpenter, and now we need to see why do we really love Karpenter so much? What made us go to this choice after all? As you have Peaceful Homer there, or Happy Homer as I call him, it was quite easy to install a bunch of operator-based Helm installation and certain roles that you would need to provide for it. And the only thing that Karpenter expects from you is that you create a default provisioner for it. What is a provisioner? This again would be more in-depth told to you by Pasi. So then I just call on Pasi then.
Okay, Yeah, thanks. Yeah, so here we will do like a short step through what the provisioner actually do if you're not familiar with this concept. So generally, if you are working with Kubernetes, so it's you're familiar that when you deploy something, there's a scheduler who makes the decision that where should I put this pod. And in those cases that there is no node, or let's say it's not suitable node, we come to that later, then it actually creates an event that I can't schedule this pod anywhere. And then in this case, Karpenter comes into rescue. So then it tries to find you an optimal instance where it can put your workload to run. And also what this optimal then means we will look at later, and it depends what your requirements are and so on. But basically it starts you and a node. So it does also the communication to the cloud provider side and sends the messages, which will then actually start the machine. So this was like on a simplified level what this provisioner does. But in Karpenter, it's not only about starting and stopping nodes, but Karpenter brings also like more sophisticated features. So this is one of them. It's consolidation. It's pretty newish, I would say. So in addition to that we are just starting and stopping nodes. In this case, if we use the consolidation, we basically give Karpenter free hands that can you please take care of the nodes and just start and stop those that are best. And also it takes in the consideration the pricing, for example. And and then based on this, it then moves the workloads and basically handles the nodes for you. Another thing is that there are these it uses well-known Kubernetes labels and annotations. So you can use these then in your workload, for example, to define that what is the architecture, what is the availability zone where I want to run my workload. And about these annotations, so from these both there are also some specific that are only for Karpenter, and one of these is related actually to the consolidation. So you can say in your deployments that for these workloads you shouldn't do any consolidation. Another topic where you can use Karpenter's features is reserved instances. So if you have bought these kind of instances, let's say that you buy some specific instance type, then you can create a provisioner where you say that, or you could name it with this instance type, and then specify, for example, also a limit. What is the limit? How many of these nodes basically this provisioner can create, and make in that way use of your reserved instances. And then, there was mentioned this default provisioner. So this is something that needs to be installed, that you can at all use Karpenter, and with this default provisioner you like give complete freedom. So in you can think about it that it's you have these levels. So there's the thing that the cloud provider provides you. That's the whole scale of the instance types that are available. Then you have the provisioner, that's more like the system engineers who can then define like a limited set of that, and then from your workload you can still make decisions. So here are some let's say like use cases where we have created our own provisioners. So one of these is we want to use that for specific networking. So let's say we can specify like subnets, for example, that this provisioner will provision only in certain subnet. One use case where we are also have created an own provisioner is that if the team has elastic IPs, so they have an elastic IP pool, and then this provisioner will create a node, but also switch the IP in this node and replace it with the IP from the with the static IP. Another thing is that basically with using these provisioners you can create guardrails, kind of protect the team so that they don't, for example, use really expensive instance types, or maybe provide some kind of like to make easier to use defaults, so they can, you could basically define that I have like small, medium and large instances and then choose that and not care about what actually the specific instance type is. And then yeah, specialized instances, that would be like if you want to use instances with GPU. And another thing related to provisioners, you could define provisioners that create nodes that run for a longer time. You want to make sure that they are not being removed that easily. Or then the other side, like this default provisioner, is that yeah, it can be removed, the node at any point. It doesn't really matter. My workload can just handle these kind of interruptions. So you can also handle these kind of things with a provisioner. So here's an example, a little bit of code anyway, we try to put in. And so this is a really simple default provisioner. So there in the beginning you see this consolidation that is in this case enabled. And then there are this part where we are using labels. So there's in first part we specify that with this provisioner you can use both spot and on demand when you start nodes, and it will then prefer the spot if it's available. Then also architecture. So with this provisioner it's possible to create nodes of both of the architectures of Intel and ARM. And then, yeah, we have also these three instance categories here defined. Then this TTL seconds until expired. This is for the rotation of the nodes. So we, for example, have this requirement from the security that we need to replace the nodes every 7 days to get the latest AMI for the security updates. And then this last one is grayed out because it's optional to the consolidation. So then you don't give Karpenter free hands to manage the nodes the way it likes. But in this case, you specify that after this time, when the node is empty, it should be deleted. And yeah, here's a screenshot about the provisioners and how much different nodes we have. I think this is from today. Yeah. We took it in the morning, and yeah, here are some of those examples. And then we go to the maintenance.
Thanks. Yeah, so now you know a bit about Karpenter, so maybe you would be thinking, what should I do actually to, from a developer's perspective or a maintainer's perspective, what should I do about Karpenter? Yes. I think you all looked at the both availabilities that we have there. We have some spot and on-demand instances and this fallback mechanism that Karpenter has built in. So you wouldn't have to worry. Let's assume that you need 100 spot instances and there is no availability, which is very rare. And if there is, if you couldn't find a spot node, then Karpenter basically falls back and spins up an on-demand instance for you. In the phase of monitoring, Karpenter emits a lot of metrics, which we then utilize them and push them to Grafana and make quite interesting dashboards. Was one which Pasi just showed, which was a really small one, but I think I have two more for you. I don't know if this is visible from the back, but this is also quite recent. We picked this up this morning. So it gives you a nice overview of what your node summary or node usage looks like, looking at the instance types, and something that's important for us is a capacity type. So you see a nice on-demand versus spot. The list is really huge because close to 500 nodes now on our EKS clusters. But yeah, fairly we have a lot of spot usage, which you could see in the snippet below, we hover somewhere around 96, 97% of spot usage. This is really nice, gives you a lot of savings, and yeah. Yeah, so probably since you've probably learned a lot about Karpenter, or this could be something new for you. For us, also, we learned a lot of lessons going production with this. Firstly, I think most of you all know about these T-family instances. They're really cheap, and they're really cost-effective. But something that we realized was they're of this type called burstable. So they're really not nice for production workload, and they start to throttle once you request more CPU or memory on them. Yeah, this was a really nice journey for us about this volume attach limit, where this is more into the Karpenter's community, where there was a bug where the Karpenter controller was not sort of adhering to the volume attach limit that you have on nodes. And we made a quick issue, created an issue, and they were able to solve it for us. So this was something which was really nice, that we have such a huge community support for it. Yeah, this, I think, again, talking about a bit about node consolidation, it's when Karpenter decides that it can right fit your workloads on different sort of nodes. So it wants to move your workload around and sort of packs them more aggressively. This is okay if it's a front-end application and you have multiple pods that are taking your workload and moving them around. Not so nice for batch jobs, not so nice for long-running workloads that you don't want interruptions. So this is also something that we figured out that this is not ideal for us. So we have a separate provisioner that's called the long-running provisioner. Maybe somehow you would have looked at it. So we have a different provisioner for that. Yeah, and probably this is also quite interesting for us. Karpenter cannot eat its own dog food. That's what I would say. So it cannot run on the nodes that it provisions. So this is something that you would also have to keep in mind. So we have a separate auto scaling group, which we call as the system nodes, where most of our tooling sits, and Karpenter sits also here. Maybe some of you have a thought or an idea, why not go Fargate and run Karpenter there? It's probably a limitation on our VPC, where we have a private VPC that really cannot make this possible for us. Yeah, this was also an interesting lesson for us, as well, when you're running workloads, your most hidden costs come from network traffic. And this was an eye-opener for us, that inter-AZ traffic is much cheaper than if you go across the AZs. And so limiting workloads within your AZ, so it's first cost versus availability. If you want your workload to be available on multiple availability zones, then you pay a bit more. So this, also you could factor this topology spread into this well-known labels and get over this issue as well. Yeah, so Pasi would speak a bit about the wonderful community that Karpenter has then.
Yes, thanks. Yeah, as you see, the community is really nice here. And yeah, we have had really good experience also with the Karpenter because of the support that you basically get. So the first thing we really liked is that the documentation is really clear and really well written and maintained also really well. So this is also kind of because we are a platform team, and this is also something that we do. So we create documentation for the development teams, and it's not that easy. So it's kind of you learn to respect this kind of good documentation, and we are really happy about this one. Another thing what Ajay also mentioned here, that in the case we had problems, we created issues for the Karpenter, and they were people from Karpenter were really quickly responding, trying to find solutions for us. And actually before we go to these issues, we always contact them actually directly in the Slack channel and ask there for support, and maybe it can be just solved there, and if not, then we create an issue and then continue the discussion over there. So yeah, I think that's basically it. We have come through the whole journey now. So yeah, in the beginning we had a look. So what it is for us as a compute platform team to work at idealo. We had a look like way back to last year to see how it was to run Black Friday from the data center. And yeah, had a little bit told you about how it feels for us to be moving to the compute or to the cloud. And then as a one tool, how to manage this new environment, let's say. So we told you about Karpenter and yeah, how we use it and some examples. And yeah, I think this was basically everything. So we were done with Agile and thought about, and I had a look at this and said that I think everything is covered. So we have like we have the servers, we talk about processes, tool we have, we talk about costs, like everything is covered. But then we thought that I think it's like something is missing from this picture, and then like where are the people actually who are doing this stuff? So there was this poor engineer who was like cursing his brain off with these hardware servers and trying to get things done. And but in the end, if you think about it, this was something that we learned to do, and we got experience. We maybe trained years to get familiar working with all these things. And now there comes this point that we go to cloud, and then everything changes. So you need to like learn new tooling. Basically, you make a kind of like a decision also. Is this something then what I want to do, or would I prefer to do something what I was doing? So it's also this kind of like a technology break, if you think about it in a small scale, let's say so. But for myself, I can just say that I'm really happy that I can be part of this migration. So I have experience what was before there. I can maybe build on that, have experience about this one. And really also excited about the new opportunities, things I can learn in this new environment. So yeah, I think that's basically it. Thank you.
Just a reminder that we have a Q&A now with questions you can ask right here, and we also have Slido, don't forget about it. We also have, I think, 3 questions over there right now. So, and we also are having a snack break after that. So I would say we'll answer maybe 3 questions from Slido and 3 questions from here. With first question from Slido, that is from Roman. Did I get it right that Karpenter runs on the top of the EKS when deployed in AWS?
You want to take that? I can. Okay. Yeah, I don't know, maybe a hand. Yeah, so basically, yes, it's sitting on top of your EKS cluster. It's your orchestrator for nodes or workloads that we have. Maybe we can hand you in a mic, which is really nice. It can be thrown at people.
Oh, cool. As for me, yeah, I had a very little experience creating my own EKS cluster, and the most thing I didn't like about it was the price. Yeah, actually, what do you think about the price of EKS, and haven't you tried some other options to avoid paying too much money?
Well, I think we made our journey, and it was quite clear that we had to go the AWS route. And then the only way, either we would run the cow rancher again there, which was a huge no. I think maybe a lot of people agree to that. But yeah, so EKS was the only way for us. And cost-wise, if you think a bare cluster for us costs around $400 a month.
Okay, I could agree that for idealo it's not too much money, but for me it was. Yeah, thank you.
Yeah.
Thank you. Then one question from the audience. Over there.
So, what are the features you're still missing in Karpenter and looking forward to be implemented by the developers of that product?
Something that you can.
Yeah, it's so perfect. So,
I mean, to think about, yeah, I mean, they have everything covered, right? So they have this multi-architecture support. They could, nothing that I can think of right now that comes to my mind that there's something missing for us. Other than other cloud providers, Karpenter doesn't run on, so maybe that's a downside. But since it's owned by AWS now, so I think that's a call that they would have to make.
Thanks.
Yeah.
Yep.
Okay, I already have the mic, so I just go ahead.
Sure.
I actually have two questions. So the first, you said like your example was Black Friday. Is it now that you don't have to worry about Black Friday anymore, or do you still have to do some work before Black Friday comes? And the other one would be like you're using a lot of spot instances. What do you say about price comparison, like reserved instances, spot instances?
yeah, about being worried about Black Friday. So I think you should be if you're an engineer working in this area. But it's kind of then you have also more confidence in that sense because there is a place where you can then scale. There's more capacity available, and then you don't need to worry about that one so much. And what was the second question? Sorry. Price. Okay, yeah, the pricing. Maybe the thing is that because this is still quite new to us, I think we don't have that kind of statistics really about spot and reserved instances, and we are also thinking about maybe the reserved instances is maybe not the thing that we would actually be using. So we would maybe use this. You are actually the pricing expert, so.
Just to add to that, so it's basically what we do is we have an overarching savings plan. So that sits on top of all AWS accounts at idealo, and then you get some discounts on top of that. And then you use Spot, then it's even more cheaper. So reserved instances was not such a good idea because then you lock yourself into one or two types of instances. So the savings plan is across all compute. So Lambda, ECS, Max, all of that. So that way it works for us.
So it's more flexibility.
Yes, yeah.
Aaron?
So I have not so much a question, but an ask that that you come back next year and give the same talk about after Black Friday.
Yeah,
right.
I think
Because obviously this will be your first Black Friday under this model, as I understand it, right?
Sequential, you mean?
Yeah. So exactly. So we want to see
Part
the
two.
sequel to this talk.
Yeah, I think that makes sense.
Yeah.
Thanks.
Okay, we have two more questions also from the Slido. Are we using node template for each provisioner? I think it's one of your colleagues, maybe.
Perfect. Pasi?
I think we used only one. Oh, we have two. No, we have two different, I think so. Yeah.
Maybe whoever wrote the question. Hi. Hi. Yeah, maybe you need the mic. Throw it.
Okay. Yeah, thank you.
Maybe elaborate a bit more would help.
Yes, because you telling about using the provisioner for the other purpose, like a node, special node, and I know that we have in Karpenter we have the AWS node template that we can choose the specific node or the security or the AMI. So I don't know what the system is using that or not.
Actually not, because that's mostly used for your auto-scaling groups. So that's different, and the only way that we interact with our nodes is through Karpenter's provisioners. So we have, 4 or 5 of them with the default one, and that's the only way that we interact with it.
Okay, thank you.
And the third question from the Slido: how is the Karpenter node scale up down time comparing to autoscaler?
Again, maybe hands up. It was you again.
I want to know that the scale up and time you have some performance measurement for it comparing to the auto scaling.
Yeah, that's a nice question, because we have Karpenter that runs on a auto-scaling group, and we have Karpenter that's spinning nodes for our workload. And when Karpenter spins up nodes for our workload, it's in the order of less than 30 seconds. We have certain health checks that we do before we actually put the worker node available to do some work for you. And for the auto-scaling group, it's a bit more different because it takes a bit more longer. It needs to do some termination checks, so it needs to remove it from the auto-scaling group and add another one. So for us, what we saw, the ASG is really slower than compared to Karpenter. So there are days that we got nodes less than 10 seconds. There are days that it took a minute or two, but on an average, 30 seconds is not that bad.
Yeah, thank you.
You're welcome.
I want to ask one more question, please.
Sure.
Yeah, you telling that you're using the reserve instance. Why don't we fix the Karpenter using the reserve instance instead that we use the multiple instance, like we use the big instance, right? And we use more instance, right? And we also buy the reserve instance. So what instance we use in this situation?
Do you mean why we don't want to use reserved instances?
Because the Karpenter, they can choose the big instance like a C5 or R6G, and it also can use the T instance, T-type instance like a T2 or T3s, and you can buy the reserve instance to saving costs, right? So what's the instance we use in this situation?
So for us, at least for production workloads, we don't use the T-type instances, so that we're clear that we omit them from the provisioner. And for reservations, like I think there was another question, we don't want to go reservation way, because then you lock yourself into a certain instance family. So let's say only C5, and let's say in Black Friday you need 1,000 nodes, and if AWS says sorry, then it's going to be a bit of bad stuff for idealo. So what we do is we have a overarching savings plan, and then we don't tie Karpenter's hands, so it just picks what it feels is the best. But also you need to keep in mind, like if it just spins up a C5 25x large or something like that, which costs you $100 an hour, then that's also quite bad. So these are these guardrails that Pasi was talking about. So we don't give it full freedom, but we make it feel it has freedom.
Yeah, thank you.
Typical government. Thank you very much. One last question from the audience. Yep.
So my question is regarding the AWS Fargate thing. So well, if you can elaborate on it, like, was it a Fargate limitation in terms of running the Karpenter, or is like subnet limitation in terms of IPs?
It's something that's a limitation from our side. So our VPC is a bit, I would say, special. It's more protective, I would say. And Karpenter can run on Fargate, but not on our setting because of our VPC.
Okay, and just one quick question is regarding the spin-up time. So when you said the spin-up time can be 10 seconds and 30 seconds, it's like with the vanilla AMI, or it's like you also having some other tools on top of the base AMI. That is also like.
Yes, it would play a crucial role, but what we use is a bottle rocket AMI, so it's really lean, and that would definitely affect how fast your node spins up.
Okay, yeah, thank you.
You're welcome.
All right, thank you very much. That would be it for this session. If you have more questions, you are definitely welcome, I guess, to just come to the guys and talk to them about this.
Yeah, maybe one last thing. So when I now have the mic, maybe the last time today, a really big hand for Rico for organizing things. So this was actually my first presentation at the meetup, and this wouldn't have happened without him. So really, thanks.
Now we're going to have a 30-minute break. There are snacks on the table. There are drinks in the fridge. Enjoy, network, connect, and we'll see each other exactly in 30 minutes. All right, AWS User Group. We are starting the second session. Before we start, I would like to remind you we have a Slido Q&A if you want to ask a question about the talk or about Meetup or anything else, please use this. But we'll also obviously have a proper Q&A session after this. Now I am giving over to Maximilian with his load balancer talk.
Awesome, thanks. Okay, hopefully I have luck with the projector this time. Let's have a look. Looks good. Great. We're good to go. Awesome. So definitely I love that last thing from before, that you guys miss working, or they miss working in the server room. I definitely come from a support background, so those type of works resonate with me a lot. A little bit about myself. I'm a solutions architect based in Munich. And I've been here for about 4 years. I've definitely focused a lot with customers on networking roles. That's what I predominantly do and let's say focus on. And today is definitely going to take you on a roadmap about what we talk about or what I talk about with customers when it talks about, when we talk about choosing a right load balance or anything like that. Since we did just talk about Karpenter quite a lot, I do have another colleague here, which I just wanted to mention quickly as well. He's in the back, Mehdi. And if you want to get a hands-on workshop on Karpenter, he's running that as well. So I can highly recommend it. He's also going to involve a couple of voices of the customer. I believe he's going to be inviting OneFootball and Grover to talk about it. So if you do want to do it and you want to be a part of a workshop, it is tomorrow. But just wanted to hit that out and let you guys know about that. So with that being said, hopefully I didn't miss anything, Mehdi. Great. Anyways, with that being said, I'll just continue on to the load balancers. So in regards to today, I won't be able to get through everything, but I'll try and get through most of them. And the two main common ones I'll get through is the application load balancer and the networking load balancer. To just ask quickly, who here uses an AWS load balancer? And then, okay, great. And who hasn't used an AWS load balancer? I just want to have a look. Okay, great. So we still have a couple of people who have got and use it and so on. So the two most prominent ones, which we normally talk about, or I normally talk about, is an application or a network load balancer, both serving different use cases, both being used for different environments. And I'll go a bit more about that into detail later. But for the main part, if you're familiar with the Aussie model, layer 7 is when we talk about the ALB. And then when we have layer 4, layer 3, we talk about the NLB. And we also talk about, let's say, handling large amount of requests with the NLB too. Other load balancers we have as well is a gateway load balancer. My favorite load balancer, but maybe not everyone else's favorite load balancer, is probably not the most interesting. But if you are into security, then it's definitely a load balancer to have a look at. And then we also have the classic load balancer, which still actually serves a couple of use cases with customers and can still be actually used for certain use cases. It's one of the only load balancers which still supports layer 4 and layer 7. We do still support customers who use it, but we don't really encourage customers to use classic load balancer, but there's nothing stopping you from using it anyways. And then the last one, which I also want to mention if we have time in the end, is the Global Accelerator, so AGA. And Global Accelerator is a great way of, if you have a global environment, leveraging a load balancer and then being able to kind of distribute your resources globally, similar to CloudFront, but exactly with other protocols, mainly TCP and UDP. So let's go into more of a deep dive. And let's first have a look at what would be the first load balancer. So who could think what this would be in terms of the first load balancer? We're thinking of EC2 instances as targets, Lambda functions, containers, and IP. Layer 7 routing, which I already hinted on. I think a lot of you should already understand what that is. And that is the application load balancer. So most things which customers do at least use or like the fact with the AOB is how much you can manage or offload onto it, depending on what your use case is. If we're talking about authentication, if you have Lambda functions involved or you want to add Lambda functions into your environment, it gives you that flexibility to do it. Or if we're just looking at pointing it towards an IP address or anything like that. You do have the option, where we can look at keeping sticky sessions involved. You do support WebSockets. We do have the ability to support it on Outposts, but I think Outposts for this audience maybe is not too relevant. But it is still at least something worth considering. Some key use cases for the ALB is typical website, you can have it for APIs, for advertising, for media and entertainment, depends on what you're doing. Path-based routing is the biggest advantage of using an ALB. Having the ability to route your traffic to multiple different resources is definitely one of the largest aspects which we talk to customers about and why they implement it. And I'll talk a bit more about that later. That's one point to point out. There are other routing options or traffic routing options, which I'll talk about that later. And then the idea of being able to hand off the authentication. So either the TLS side or, if you wanted to build like a zero trust type of network, you would also consider an ALB for that type of use case too. So it does allow you to let's say, leverage a whole bunch of use cases and build on top of that. And so what that kind of looks like from a high-level overview, depending on what it is which you're using or what you want to target, we have all the scaling target groups, ECS, EKS, Lambda functions as earlier, and the other things to integrate, which I mentioned, or I should have mentioned as well, is also manage security services from our side. So if any of you have used Web Application Firewall, it's a way of just being able to natively control or natively, let's say, block malicious actors on your load balancer. From there, you can then go in and just determine who's allowed in and rate control, or let's say control what you have with your environment. In general, AWS does have DDoS protection normally. So when we do talk with customers about using WAF, it's mainly to protect against layer 7 type of DDoS attacks. We're looking at those type of flooding attacks. That's where then WAF actually comes into play and is a large part as well. So that's where we would mention that. And then if you want to integrate in terms of the authentication side of things with an OpenID connector, so OIDC, you can use that, or Cognito as well, depending on what it is you want to choose. So for me, I always find the most interesting part, at least about ALBs or NLBs in general, is how they actually scale and what the back side of that actually looks like. And normally what will happen when you spin up an ALB, it is more so considered a single tenant type of resource. There are nodes which are deployed in your environment. And from here, you will get public IPs which are technically assigned a DNS name with Route 53 within your environment. Route 53 automatically handles that, and then you get these IP addresses which are assigned to these instances, and then we will automatically worry about the scaling. And the scaling then happens when, for example, you are looking at increased traffic, you have more resources, or there are other aspects kicking in. You can have the ALB scale. And from here, we will then have Route 53 adding more IP addresses onto the existing DNS name, and from there scaling out accordingly. The older IPs will always stay in the pool and will be slowly cycled off. So until there are no more live connections, until we're sure that you aren't having any more live connections running on the old instances, they will be cycled off. And in the event that you still need more capability or more scalability, it will scale out accordingly. And it will continue scaling. That's why if you read also our documentation, we will say that you need to have a minimum of 8 IPs and then up to maximum of about 100. ALBs will scale up to 100 separate nodes if they need to. So that is something worth bearing in mind for your application. But ALBs are not something which you consider if you need spiky traffic. So if you know you're going to go really fast into a workload and then maybe slow down, you wouldn't really consider an ALB. It would be more so that you know the traffic's going to gradually increase, and then you'd go that direction. So that's also something just worth pointing out. So what does that look like when you actually deploy it? So when you actually deploy it, you actually see, if you go into the network interfaces in the console, you'll see that your ALB will start spinning up a whole bunch of ENIs. And you can see these IP addresses which are targeted towards your ALB, and you can then just have a look at the traffic that's coming from it and then see where they're targeting. If any of you used anything which something you might have already heard before, VPC flow logs, you'll very much see sometimes traffic being pushed towards your instances, and you're wondering, where is that IP? That's more than likely the ALB pushing that traffic on towards your instances, and from there you can have a look at it as well. ALB IPs are ephemeral, as I was talking about. They do spin up and then they do disappear. So that's also why when we talk about static IPs, we look at the network load balance instead. That's more so a common idea. But the IPs, if you are looking for something fixed in that case, we do look at different options instead of using the ALB. So that is just worth mentioning. So then what does it look like from a logical point of view? as I kind of just hinted on earlier, the routing is the most important part of the ALB, and where we choose to send that traffic to is how we can organize it accordingly. So you can have listeners, obviously multiple listeners, and the listeners from the basic part will first be just determined by what port you want, and then any paths which you want on top of that. I'll go a bit more in detail on the next slide in terms of the different paths, but here we can then choose what target groups we want to use and push the traffic or those resources onto other target groups. If it's a Lambda function, ECS stack, anything like that, we can move the traffic on accordingly. So that is just worth bearing in mind. You also do have the option of redirecting traffic. So for example, if you wanted to have only dealing with HTTPS traffic, you wanted only authentication, you could always move traffic first from HTTP off to HTTPS, and you can set that as a rule as well. From there, what will actually look like in terms of the options which you have with path-based routing, you have whole different combinations which you can choose, and you can kind of sandwich them together as well, depending on what it is. The two most common ones are definitely the host header or the URI path, which you want to use, or it can also be the path. So a path which you decide to put at the end of your URI or the URL post or path in this case. From there, the ALB will recognize what it is that you chose as a path and then send it on to the target group. It will then allow you to, let's say, put in different aspects or different routing depending on what you want. If you're using headers, for example, let's say you have resources coming from another CDN, like Cloudflare as an example, you can also then put that as an option. You can get Cloudflare to add headers, and then from there, ingest that into your ALB and route it accordingly. It all depends on what you want to do, all the way down to source IP addressing. You can use ranges of source IPs as well, and from there also manage, let's say, where you want to send the traffic. And I think it will become a bit more important later as to why the routing part is so important. And then from there, let's say the details in terms of how it would look is you choose what method you want to use for routing, you set actions, and then you can determine, you set conditions, and then you determine what the actions are going to be. So you say, okay, if I have this host header or this path, please then do this action. Whether I wanted to authenticate it first, or authenticate and then forward, or simply just forward it onto my target group, then you can have that being done. Something which is now also being quite common is fixed responses. That's also something which customers can also introduce and use a lot of. If you wanted to just say, okay, this path here is just not being used, I can simply just put in a fixed path and say, okay, provide whatever message it is I want. From there, you can choose how you want to manage the routing. There are a whole bunch of different matches and conditions which you can add, and then forward it either onto a target group or exactly your resources as you need. And the reason why these conditions can be very important or very useful is because onto the next topic, which I'll go into, is sharding. So quick raise of hands, who knows when I talk about sharding, what do they think about? Do you think about databases, or do you think about something else entirely? So who's thinking about databases? Okay, so if I said we're going to use load balancers for sharding, would you raise your hand and say, yes, I know exactly what you're going to be doing? So raise your hand. Okay, great, one person. So sharding is a great way in AWS, and it's also something which I'm going to talk about later, of us to be able to distribute our traffic in a controlled manner so that we can incur less or increase our resiliency, and also ensure that we've got less downtime as well. How does it look like? Imagine here, this is our traditional architecture, and we're just using groupings of the icons above. Yes, it's your choice in terms of how you want to group them, but I've just grouped them this way. And let's say we've got a bad actor, the cat. We can imagine the cat is always just causing problems. It's just an example for this case, right? Let's just say that the cat has done something to one of our EC2 instances behind a load balancer, which has caused either misconfiguration or has caused that instance to stop replying, and it's knocked it out of our target group. What will then happen is that instance will then get cycled out of that target group, but the cats will keep replying and keep asking, well, I didn't get an answer, I didn't get a response, take me to the next server, take me to the next server, take me to the next server. And then as you can see, it can take out all the servers, right? So what does that happen? We impact all of our groups, and all of our customers here are technically impacted because we haven't implemented sharding. So now when we actually have a look at sharding and what that looks like, we can now break these down into separate groups. So now let's instead group the cat and the dog together. It looks like best friends or mortal enemies, whatever you want to consider. But regardless, let's group them into a group. And now let's say that each separate group is their own separate target group in this case, right? When we have that same type of issue and there's a misconfiguration issue, or let's say it's a potential attack as well, we're finding that, okay, in this use case, only the cat and the dog are actually impacted. The instances there are the ones who are impacted, and everything else is still fine. So we're still working our way up. And here we can clearly see that we've actually had a net gain, at least, and we've impacted less customers in this use sense without bringing down the rest of our service. But technically, couldn't we do better? We still had 2 targets, which were affected. Couldn't we still improve this and work on this? And that's where the idea of shuffle sharding comes into play. And that's something which we also use internally, and this is also why I wanted to mention a bit about this. Shuffle sharding is the idea of being able to rotate the different groups onto different resources. So here, for example, we'll take the cat, we'll put them on the first and the third group. We'll take the other options like the rook, the second and the fourth, the knight on the first and the second, and so on, until we have our group assignment sorted. From here, we then say, okay, now the cat comes in and exactly takes down one of our instances again, right? Here now in this case, we can see that the first target group is affected and same as the third target group. But we're also noticing that the knight and the queen are, let's say, also have other target groups which they're associated to. So the knight itself, even though it is part of one affected target group, still isn't completely affected and still can resort to dealing with resources or dealing with customers and then handling workloads. Likewise, also with the queen. We know with the queen there that she's also got resources there and can handle traffic on accordingly. And now in this use case, we can still see that other than the cat now, or only the cat now in this example is affected, and everything else is actually green. So we've technically gained it from a net positive, and let's say we've improved our use case. And we can only, let's say, continuously improve this with customers depending on how many customers we have and the amount of combinations we can potentially have. So the amount of shards which we have. So if we actually increase the shards, we can also still increase, let's say, our resiliency. But that is still a fine line because we still need to make sure we can still cater to our customers while not, let's say, oversharding, right? The last thing you would also want to do is overshard. And that's why, to put in perspective, what does this kind of mean if we look at the observations, right? So let's take an example of 100 nodes. The EKS cluster was how big, as an example? Is probably like, let's say, a couple thousand. How many nodes do you have in your EKS cluster? 500. Okay, so then that also works pretty well as a good example. Say we've got 100 nodes, 5 nodes per shard here. The chance of there being an overlap, technically of, let's say, 0 instances, or just 1 instance, I should say, is 21%, right? So just for one overlap in terms of one customer, overlapping is 21%. And as you can see, for the fact that one customer to share 2 instances goes down to 1.8%. For customers to share 3 nodes, it goes drastically. And then it starts getting to the point where it becomes minimal, if not negligible. And the reason why this is important is because this is how Route 53 enables or guarantees such high uptime, because this is exactly what Route 53 does in order to ensure that you can always make demands or queries to Route 53's API. As an example, per region, we can have 2,048 worker nodes, and we have about, how many shards? Shuffle shards, and 4 worker nodes per shard, as an example. This way then here, we can ensure that the chances stay minimal, and that's why we can guarantee such a high uptime, as an example. And from there, you can then just choose and play around how you want to implement your setup. As I talked about the traffic routing earlier, the traffic routing determines the groups which you set, and you can choose how you want to then set those groups accordingly, whether you want to group them by source IP, as an example, whether you want to do it via query string, whether you want to do it via HTTP header, that's completely your choice. From there, you can then set what you want to set up and implement that within your workloads as well. So I think sharding is definitely a nice aspect, and it comes into play also later with NLB. But the last thing with ALB, which I just wanted to hint on, was traffic routing as well. As default, an ALB will always round robin your traffic. And what I mean by round robin, it'll just simply send it on to the next instance, which is available, and it'll just send it through in a round robin type fashion. For the ones who are maybe a bit more savvy with, let's say, AOB, there was also a new service released last year, or I think the year before, I have to double check, with least outstanding requests. And with that, we can actually take the option of saying, okay, how many requests has each instance had? And then from there, choose, okay, where are we going to send the traffic to? And only send it to traffic with instances with the least amount of requests, or the least outstanding requests in this example. Then once we've noticed that we've actually hit the limit and we need to scale, we can then scale out our load balancer and we can scale out our instances. But now you can see the new instance which comes online has pretty much one outstanding requests. So it is going to get technically flooded, right? So what we can also do instead to avoid this flood is implement a slow start. So on the target group, you could set slow starts so that the AOB doesn't flood that EC2 instance. And then from there, we will slowly gather and slowly increase the resources onto the instance until it can scale out accordingly and then be implemented in the environment. This is just something which if you want to implement now, it's just a click of the button. You can change and then you can implement. It's completely your choice how you want to do it. But it is a great way of being able to improve latency within your environment. And it can be, let's say, beneficial for managing instance performance as well. So it's definitely something which, if you have a test environment, test it out, see how it goes. Not all use cases benefit from it, but most cases will. And then just have a look and see if it works for your environment.
Can you say some use cases where it's not a good fit? And why would it fit with the default?
So WebSockets is probably something where you'd want to be cautious with using. So long-lived connections in this type of example, you would probably want to be cautious with that, especially when you look at hitting a new instance. That's something which can be problematic. It can lead to either connection being dropped or anything like that. Maybe not something which you want to have happen. So that's the one situation which I would be cautious of. If there are others, yes, could potentially be, but WebSockets is for sure one. So great question, for sure. Great. Then I'll go on to our next type of thing. So I know I've hinted already onto it quite a bit, but now let's talk about the next load balancer. This one here, I think you should also probably have an idea, since I did mention the layer as well, talking about layer 4, but what's probably more so interesting is the ALB as a target and the idea of having long-lived connections. This is when we talk more so about an NLB. Our NLB is something where if you are looking at handling large amounts of traffic in terms of a spike and a really quick workload, then we look at an NLB. It is something which I'll explain a bit later can scale a lot faster than what an ALB can, and then can also deal with or manage your traffic as well. In terms of typical use cases, what we see is we can see things such as games being used quite often, and I see it being quite used with IoT as well. IoT is probably the most common use case. You've got, let's say, hundreds of sensors needing to upload that information to the cloud, and you still want to have TLS termination being done. That's something which the NLB can offer. You can't build from all these IoT devices single VPN connections up into the cloud. It's not going to scale. So you have to use TLS connections, send it through the internet, of course, and then terminate that on the NLB. And that's something which the NLB can provide and offer you as well. What it looks like from a high-level point of view, we have services like Private Link, which you can natively integrate with NLB. We have, Certificate Manager, and then, of course, as with the ALB, we have auto-scaling ECS, EKS as targets, and then we can also send traffic to on-premise as well, if we would choose to do that as well. From a high-level overview, the NLB is much simpler than the ALB. There is no path-based routing. It's a very, let's say, simpler NLB or load balancer, but it is meant to be like that. So we would mainly choose to route traffic based on ports. And then we say, okay, based on the ports, whatever it may be, we choose to route that traffic according to whatever instance or whatever resource, whichever we want to do. There is no Lambda as a target. That's something which NLB doesn't support as of yet. And then the more so interesting part is definitely, for me at least, how does NLB scale? So has anyone heard of hyperplane before? I knew you. And has anyone else heard of hyperplane? Okay, great. If Mehdi's still here, I expect him to raise his hand. Yeah, there you go. Great. So hyperplane is what we call internally. It's let's say the service which manages or is the backbone of a lot of other services. So if we talk about services like NAT Gateway, Private Link, the network load balancer, transit gateway, the network firewall, it is how we're able to keep uptime or keep that scalability on all these different services. And how it actually works is it is a multi-tenant type of solution where exactly how I mentioned earlier about shuffle sharding, and that's why I wanted to hint on shuffle sharding, that's exactly what we are doing on the NLB instead. So we take a whole bunch of nodes, hyperplane nodes, and we distribute your resources onto a whole bunch of nodes internally with us. That will then be represented by a single ENI. So as you can see, that's how we have a single ENI in this use case. And then we scale that up to each individual customer as we need. And then of course, that applies over multiple different AZs as well and can scale out accordingly. So then with this use case, you can see that we have that fault tolerance, and we also have that ability to scale really fast. So we can scale up to let's say, a large amount of connection requests compared to the ALB in this example as well. And then what that would actually look like in terms of your environment, we would see, okay, great, we have now got our VPC with our AZs. We technically have that network load balancer, which we know comprises of a whole bunch of hyperplane nodes. And from there, we can direct the traffic first to those hyperplane nodes and then onto our targets in the background. Of course, we also use Route 53 in the front of the ENI, and then we would actually say to Route 53, okay, please direct your traffic to this ENI and send the traffic on accordingly, and then from there, we can manage that as well. From there, this is something which customers don't see. This is all something which we manage internally, but that's how we're able to keep reliability and keep scalability on our NLB and exactly provide that to you as a customer. And so what does that look like in the VPC? Much more simpler, much easier, and something we don't have to worry about either. So then just the last two aspects, which I just wanted to talk about quickly in terms of the NLB, was the use of Private Link. And Private Link is now a very common use case for SaaS providers. So if SaaS providers are looking to share or let's say allow you to use their resources from one provider to another, take for example, Snowflake as one example, they can allow or they can deploy endpoints in your account, which then go over our backbone instead of you going over the internet. Regardless, even if you go over the internet, you're still going over our backbone. So if I take one public EC2 instance and another public EC2 instance, you're still going over our backbone, but you are paying additional charges for that type of communication. In this use case, we are just going directly over the AWS backbone, and then whatever resources are behind that network load balancer can then be used. So in this case, we just have two EC2 instances. We can imagine one account is on the right, and then the provider is then on the left. And that's just one great way of being able to provide a dynamic way without having to worry about IP address overlap, and also a scalable way of consuming resources. From there, NLB can also be used as a target for an ALB in the event that you want to, let's say, move traffic on to that. That's probably more so of a use case where we want to use NLB or we want to take advantage of Private Link and we still want to direct traffic to an ALB. That's usually then a very common use case. If you don't need to, or if it's something which you can, let's say, avoid, then you can just go through public communications, but ideally then focus on that type of aspect too, or in this case, use NLB to target an ALB as well. And then lastly, just in terms of NLB, which I just want to mention, is the idea of zonal names as well. So as I mentioned, you have ENIs in each individual AZ or each individual availability zone. In this example here, we can always direct traffic to a single availability zone as we need as well. So of course, if you've worked with a load balancer, you know you get normally one public DNS record. We can actually say, okay, but if I just want to now send traffic to that single ENI, I don't want to send it to all of them, then you can choose to just select the one availability zone over the other. And why this is quite important, I can imagine a lot of you might know of inter-AZ costs. That's something which I've spoken extensively with customers about. This is one trip, or one tip, I should say, which you'd have to involve or use in your environment to, let's say, help reduce that. And then from there, build your architecture along accordingly. And then I just wanted to mention just the last thing, which is the sharing, or the two type of features which are shared across both of the load balancers, in this case, the NLB and the ALB. And first is just the distribution of traffic. So one important thing which also customers tend to miss out on, or tend to, let's say, forget about, is the distribution of how it is across AZs. And what sometimes actually happens is that in the use case where you have cross-zone load balancing enabled, you'll notice that we will distribute the resources equally to all instances within your environment. But if you choose to disable cross-zone load balancing, and this is more so, I'd say this is more so important with an NLB, you can still do it also with an ALB as well. But the reason why that's more so important is because what can end up happening is if you disable it, you can end up sending 50% of your traffic to one instance, where then you start only sending 20% to the other instances, another AZ. As you can imagine, this happened to a customer of mine, and their one instance just went down. They didn't understand why. It was very simple, just to put in perspective. Okay, it was the fact that you set up the routing incorrectly here in this use case. So it's also definitely something which I talk to customers about, managing their target groups, managing their workloads, making sure they're spreading it out accordingly. If they even can, having target groups in each AZ. But yes, that also comes with challenges too, so not always something which you need to implement. And then another tip as well is the idea of choosing the right health check. I can't emphasize that enough. A lot of customers just decide to implement a single health check onto a single application instance. And this is something which we would consider a shallow health check, where we're just checking the EC2 instance to check if it's available and see if it's responding to requests. Now, of course, we can do that. But imagine the case that the application server can't make a request to a database in the backend, right? Imagine the database just stops responding, it doesn't give us any reply. How would we check that? Because the load balancer, or let's say the load balancer, is still receiving information from the instance that it's healthy, right? So it's saying it's still healthy, please send me traffic. And then when the traffic gets to the instance, it can't actually pull any data from the database, it's offline. So what we do instead is we actually take advantage of using deep health checks, where on the application instance, you want to have a separate check on that database. So you want to say, okay, have another path, which I use, which will check /health.html. If that is responding at 200 code, then I know, great, that connection is active. If it is responding at 400, then I know, okay, that connection is down, and don't send traffic to that NLB, or sorry, that instance. And from there, you can ensure that you're always handling traffic accordingly and that your users aren't impacted. Because one also issue with this type of configuration is that for the most part, the only way you're going to find out about it is either A, if you have an alarm on the database, or B, if users are telling you about it. And you ideally don't want users telling you that your website isn't working. So that's an important thing to mention. And lastly, if you are in an environment where all of your instances all of a sudden start going red and they all just saying they're unhealthy, the ELBs in general, so all ELBs here, will just automatically do an open fail and send traffic to all of your instances. So that can cause some fun use cases. So just be wary of that too. That is something just to bear in mind too.
In that scenario where the database is not responding, all instances would fail. Right?
Yes, yeah.
So that's when you want it to fail open, because then it could be that some requests are still being handled, or is that what, like, this is the behavior that I always have to have discussions about?
Yes, you would.
Fail open is
yeah.
Like some requests might be going through, the database might still be doing some work, but all the instances are unhealthy because your health check's failing.
Exactly.
And so feature to say in A or B that that's not desirable? Don't send traffic to unknown users. Sometimes shallow health checks are good, and sometimes they're also deep checks are bad because they also give you a false sense of availability, right?
Yeah, for sure. But the one thing I'd definitely say is that as long as you're prepared for either one, then you're fine. If you're not prepared for either one, then it's going to smack you pretty hard. Exactly. So, yeah, exactly. So that was just one thing which I'd want to mention as well. As long as you're prepared for it, then I think you're fine to handle it. And then from there, just looking at time, I think I'm a bit over. I also want to just answer some questions. So I'm going to say thank you for now. And if you have further questions, just feel free to come up to me and then ask anything as well. The two aspects I didn't really get to talk too much about are Gateway Load Balancer and Global Accelerator, but feel free to ask me questions and go from there. So I believe we might have some questions, or did we already ask?
Of course, I closed the browser. Yeah, so we have actually plenty of questions on Slido. So we'll try to answer those, and also a couple of questions from here. Yeah, first one, what are the layers on load balancers?
Layers? Oh, sure. So the Aussie model, the Open System Interconnect model, if you're not familiar with that, that is just the different networking, or let's say the networking protocols which we determine or which we want to use. So, for example, level 1 is just the basic connectivity, level 2 is data link, level 3 is an IP connectivity, and so on. And then layer 7 is mainly then when we talk about HTTP traffic, that's mainly when we talk about layers and what that's being used. If that's not something familiar, I'd highly recommend Googling it. I wouldn't want to exactly mention it. I wouldn't want to bore everyone right now by going over it. So I can just remember Googling it rather than hearing my silly answer.
Okay, we have some more questions there about sharding. Let me give them. So first, can you please tell more about sharding? Is it like a health check group, how the load balance distributes the traffic in sharding mode? Second one, are we assuming a sticky session behavior in the sharding scenario? And just to confuse you a bit more, there was another one. Is it hard to set up the shuffle sharding on LEBs?
Got it. So the first one was what, mainly just tackling about what if we're using it. Okay. So the main idea with sharding, which you want to implement, is I'll probably tackle it with the last one, how hard it can be. That's definitely a question about you and your teams need to ask yourselves if you want to implement it. Is it worth that amount of time to go over and change it? Do you consider this resiliency important to you? That is something which, of course, at AWS, we have to implement at scale for customers. So we couldn't implement or have our workloads without implementing that. So we recommend to do that. Of course, not something you need to do, but it goes back to our shared responsibility model. What customers choose to do is then imagined in their environment. And what was the second question? Because that was the one was meant to confuse me, right?
No, the second one was, are we assuming sticky session behavior in the sharding scenario?
Oh, right. Yes, we are definitely assuming sticky sessions in the sharding scenario. So when we have, let's say, when we're talking about most of our connections here, we're always considering sticky sessions as part of that. And then that's where the load balancer will always check, okay, how many sessions are still active, and will slowly drain the sessions if we need to, let's say, revert or change flows accordingly. Otherwise, if you do have situations where you have to change your environment or you have to reinitiate a connection or flow, as we call it, then that's something which either the user will have to initiate or you have to then bake into your application. But for the most part, AWS will make sure that no flow is broken or interrupted. We will gracefully swing that over. So yeah.
So questions from the audience. Okay.
Hi. One question regarding load balancer architecture. Would you recommend having a single ALB for multiple applications, also in terms of pricing, or would you rather go for having a separate load balancer for each application?
Yep, so there are definitely many ways of looking at that, and it really depends on how you want to branch it. You can have one ALB managing everything. There's technically not, I wouldn't say it's not a bad practice, but you can still do that. It is just determined on what, let's say, resources you want to distinguish from another. If you, let's say, have authentication or other requirements, then you can do it. I would always be looking at the limitations first. So remember there are 100 rules which you can set on the AOB. That's then a key limitation, so it's technically 100 applications you could have on it. And then if you need to go above the 100 nodes as well, if you know you're going to have to scale across more than that, then yes, you'd also want to look at using more AOBs as well. But regardless, that is quite fine-tuned. And it's definitely worth looking at your metrics first and saying, okay, what are you currently hitting? And then determining, okay, should we break off segments or not? And then you can or you should be using either DNS or the idea of, let's say, weighting the target groups as well to move the traffic accordingly. So there are multiple ways of looking at it. And it's hard, I'd say, to give like one definitive answer for it. But if you can, move it to multiple ALBs, try and do that for sure. Otherwise, then try and branch it out as much as you can.
Cool.
Yeah, there we go. It's much easier if you throw it.
Yeah. So the popular scenario of having the apex zone in domain name. So what do you recommend? So NLB and global acceleration, I guess they're the good two options in this case. So what is the pros and cons of using each of them?
Between an ALB and a global accelerator, or an ALB and NLB?
Yeah, ALB, I guess it's not the option, is it?
Yes, no. So if you're talking about the zone on it. Right?
Apex zone, the name. Domain name.
If you wanted filter based off of that, you can really only be really using then the ALB. If you want to get, let's say, more granularly involved, you can still use sharding through Route 53 as well, where you move traffic and then around to different NLBs accordingly, or you do 50% of traffic from one to another. But the NLB, for the most part, can handle that type of request or that type of traffic. So usually if you're looking at, let's say, changing or wanting to change the URL path, or let's say the Apex domain name, right? Then it's probably best to use sharding on the Route 53 side and then point it to multiple ALBs as you need accordingly. So then you can move the traffic on accordingly. So you send like a third of the traffic to one ALB, another third to another, and then another third to another instead. So that's one way you can look at it as well. You wouldn't need to have to do the NLB. It could technically handle the amount of requests there instead.
Yeah, and if the domain provider is not Route 53, and then so NLB and global accelerator are the options, right? And so then what would be the best case to implement?
Okay, so instead you don't have the records in AWS, and instead you want to then move the traffic around internally, right?
Yeah, from the external domain provider, so the IP address.
So then if you have an external IP like that and you have to move around, Global Accelerator would be my first key choice there, because you can move that to multiple load balancers. So you can move it to an ALB or to an NLB, just depending on what you choose. You get technically two Anycast IPs, and then you can also import IPs if you want to as well into AWS. That then at least gives you more, let's say, functionality to move the traffic around, and then you can weight the traffic based on what you want to with the Global Accelerator. And that could be a use case for the Global Accelerator. I would see if you can try and handle it first, then with an NLB, but as NLB is quite, let's say, basic in terms of the routing, you probably would have to go Global Accelerator instead. So that's what I'd look at. Okay, here we go. Question? I was sweating bullets there. I was like,
So it's about draining.
got it.
About like whether it's a quick one. About the differences between draining when you replace the target group as opposed to replacing the instances within the target group.
So
in terms of draining behavior, like which
right.
is preferred, right? Which is a cleaner drain when if I swap the instances in the target group or replace the whole target group.
Okay. That.
Because like I have
I haven't tested too much to, let's say, know what the benefits or the drawbacks would be. But speaking from a high level, I would more so, instead of cutting the draining, so you can cut the draining to 0 seconds, I would rather be wanting to move it over to another target group instead. For that, I haven't measured the performance there, so I can't really compare too much about that. But at least with gateway load balance and firewalls, that's usually what we do, is we move the traffic to, let's say, another target group if we needed to do that.
Always the trade-off between having to create a whole new target group
Exactly.
for every deployment, as opposed to just replacing, like the default behavior for like ECS, right? Just replacing instances and then have it drain them.
Exactly.
Whether or not traffic's like whether new traffic's being initiated, like if you're doing an ECS of 100 to 200% deployment, right? You're doubling the capacity, and then you're draining the old ones and new ones.
Yeah. You want the mic? Well, I think he's mentioned it, but you have to repeat it.
I'll repeat it. Yeah. So I guess that what I always struggle with is like whether or not when you're working with a ALB and say with ECS and about creating a new target group for each deployment, so and then swapping that into the load balancer and having it drain the target group and then bring up the new one, like so either doing it like with a blue-green swap or something like that, or just having ECS by default add new instances to the target group, say in the model where you've got 100% to 200%, where it will double the number of tasks in the target group and then start draining the old ones. And it's like how much time before why you've got old tasks running old code and new code running, like being able to be deterministic about that.
Yeah. I think there's a lot to discuss about that. So we can talk about it offline as well.
But it is,
cool. There's definitely different approach to it. So exactly. Last thing I just wanted to mention was that if you have any feedback, I'd love to hear it. It's just a survey, which would just be great for me. And other than that, then thank you so much for your time. And exactly, that's a deep dive on load balancers.
Thank you for joining us. Actually, now, after having questions to Maximillian, we have a couple of really, really short questions for you guys.
Quite some exciting stuff coming though. Just a sec. It's okay. Wait. Sorry.
That was planned, isn't it?
Yay. All right.
Okay. So shall I?
Yeah.
All right. Just to give you a heads up, we got plenty of exciting and very quick stuff coming up. Sorry. Yeah, we actually applied Ask Me Anything a few sessions back, or the last session it was, I think. So we want to turn it into a habit. We use Slido actively during the session, as you know. And now we would like to invite you also to just a few questions for you to answer, so we get to know you more. And we are hoping to do this every time. So feel free to join right now. And then we will have just a few questions for you. And afterwards, it will be also a feedback round, like Maximillian suggested, that you are welcome to give while we have a few more exciting session slides coming up for you. So, yeah. Right now, I see we got 22 people joined. And if nobody needs more time, then, okay, Max, you're also joining. All right. Great. So the first question is quite a simple one, that your role at your work is, right? If it's not too wide, if it's not visible, please let me know. I can repeat. But yeah, that's the first question. And then I see almost everybody responded to it. So quickly, I will pass to the next question. Just your age group, right? Between which age group are you? And by the way, all your answers are, of course, anonymous. Like, we don't see who you are or anything. So no worries. You know. Okay. So we also have plenty of responses. Great. Yeah. Exactly. Okay, and then your gender. Your favorite instance type. Next question. Yeah. All right. And finally, the last question: how do you rate your technical knowledge to AWS? With 5 stars being I'm an expert, while 1 star is I'm a beginner, and in between, right? Yeah. Okay. All right. Following this one, now we will activate a few questions for you. We will not present them. It's basically a simple feedback round, and there are plenty of questions there. You can see that if you find this session useful, and do you have any suggestions to the first session as well as the second session, or to us in general, feel free to share any feedback, anything that you would like to give as an input. We try our best to make these sessions more interactive, more interesting, more inclusive for you, and to strengthen our community in every session. There is always room for improvement. So be our guest, and we will be humbled to hear your suggestions, your advice. So this can go throughout. You can also do afterwards. And one more thing that I would like to invite the speakers of today's session, that we already had plenty of questions that were unanswered. If you're so kind, we will forward these questions to you, and if you can answer, then we will later on share also in the meetup page of the event, if that's possible. Okay, so now with this one, I will bring our presentation. So, let's present. Yeah. Yes. Yes.
So we would like, first of all, we would like to announce that so far the planned date for our next meetup is 15th of August. We will announce the meetup, the event, probably in a week or two when we will finalize the topics. But you can already reserve the date, free up your evening, say you're busy, cancel the birthdays, everything. Just come to us. Nothing matters more. And the next one is really exciting. As we already told you, we've got we have surpassed the mark of 5,000 members, and we would like to celebrate this with the giving away one voucher to. Where's the slide? Yeah, we'd like to give away one voucher to the 5,000th member, who, if he or she, probably she is here, would need to approach us. Is there a Claudia today with us?
If Claudia was supposed to join. Okay, but we got a backup plan, right? So the next one.
Yeah.
Right? Okay.
Then the 5,001st member is supposed to be
Gulab Singh Ratore. Okay. And 5,002. We will go all the way. 5,002, right? Mihai Kalota. Yeah. we okay.
Marlene
Seipt.
You're here.
You're Marlene?
All right. To celebrate this, you will get an AWS voucher with some free credits. You just need to approach to us, and we'll give it over to you. Thank you for joining us today.
Also, not only to Marlene, but to thank you to all of you attending our sessions every day and making the number so big and so fantastic for all of us, right? And of course, we also want to give you the opportunity, even though you are not 5,000th member, right? Yeah. Okay.
We are doing a raffle. We've got some JetBrains licenses. They have kindly provided us with some sponsorship packages. And we are going to give away 2 licenses, and we will do it in a way that we will spin the wheel. And the number that will indicate your name across among the RSVP'd will get one of the vouchers. Yes, so
shall we begin?
We have the list with Daniel, and the first voucher goes to.
But the thing is, encourage people to actually show up to the RSVP. Second, stay until the end of the talk.
Number 52.
52. This is Felix Huhn.
Woohoo! All right, Felix, you can approach us after this meetup, and we'll give you your voucher.
Okay.
And the second person is. Member number 86.
86 RSVP goes to Laman M.
Laman? No?
Good, so we keep the voucher fast.
Let's do one more time.
One more spin.
Actually, yes.
18.
18, okay, which is Ayanash Budana. Okay.
Okay.
Yeah, well, it's 170, 70, no, 27
And now it's number 55.
55. Well, it's a name Fisher. So whoever.
Username Fisher on member.com, meetup.com.
With the user ID.
You're the Fisher.
Yes.
Congratulations.
For what? I just arrived from the bathroom. Sorry. You're going to Las Vegas. Yes, that's fine.
We're giving away JetBrains licenses for you.
Okay,
Yeah.
that's fine.
All right. Back to the presentation. So we have two QR codes for you. Sorry. For you to scan, which will be which will give you an opportunity to actually be the part of this meetup by either maybe hosting us next time or one of the next times. Can you scroll 3 slides back? Thanks. And also, if you want to give a talk at one of our next meetups, we'd really love to hear from you guys. Maybe something really interesting that you've been working on lately. It can be or should be AWS related, but if it's also something similar or whatever, just apply. We'll reach you out. One slide back. Thank you again to Idealo for hosting us, and That's it. Thank you all. Have a good night. I think we can still spend here for something like 30 minutes, 20 minutes.